What's up, guys? Welcome to lesson 3.3, multiplying rational numbers. Let's do it. All right, again, rational numbers, in case you missed it in the last couple lessons. Rational numbers are any number that can be basically put into a fraction. So fractions are all rational numbers. And even whole numbers and integers are as well. So now we've got some cool multiplication problems over here. We got 4 3/8 times negative 3 3/7. So how do we do these problems? Some people are tempted to multiply the whole numbers and then multiply the fractions, but that doesn't work. Everything has to multiply everything. The 4 has to multiply the whole number and the fraction. This fraction has to multiply the whole number and the fraction. Okay, just doing 1 to 1, right, with the numbers and then the fraction separate, it'll give you an incorrect answer. The best way to tackle something like this is to turn these guys into improper fractions. How do we do that? We take this number, we multiply the whole number against that denominator of its fraction. That gives us 32, and then we add it to the numerator. What's 32 plus 3? That is 35. So let me just write 32 over here. We write 32 plus 3, that gives us 5. Let's do the same thing here. We take, and this is just negative, so don't worry. The negative, we know our answer is going to be negative when we got a negative times a positive. Don't worry about the negative too much. 3 times 7 is going to give us 21. We add that to 3. And over here we get 24. And the denominators stay the same. That's the beauty of multiplication. They don't need common denominators. It's all good. Now we can just multiply across if we wanted to. But 35 times 24 is a big problem. I'll try and do it mentally. It's 35, 70, 700 plus 120, 140, 840. Okay, well, you could do that. It's not a great problem. But instead, we can cross off across the fractions, because when you're multiplying, this really becomes one big fraction. So the beauty is we can look at 35 and 7 and say, do they have any common factors? Well, they do. They can both be divided by 7. So 7 divided by 7 is 1. 35 divided by 7 is 5. Now that's so much better already, but we can keep going. We can do the same thing with 24 and 8. We can divide them both by 8. So 8 divided by 8 is 1. 24 divided by 8 is 3. Now look at these numbers, so much easier. We got 1 on the bottom. That's easy. And then we got 5 times 3 on the top. That is 15. Which means our final answer, anything divided by 1 is just 15. Don't forget that negative, and there you go. Now let's go on to the next one where we got to plug in some values for A and C. So again, I'm gonna start right off the bat since we're doing some multiplication. I'm gonna convert this into an improper fraction. 3 times 5 is 15. All right, and then we add 15 to 4. And that gives us 19 over 5. And then let's just plug and chug. We got 10 over 24 for A. Right? And we've got 4 over 5 for C. And that negative is going to apply to the whole thing because it's a negative times a bunch of positives. But the one negative, remember, it's like it contaminates everything. We got 1 in there. The only way to get rid of it is you got to get another negative to nullify it. So we've got everything now nicely lined up. Well, what can we do? How can we simplify this? I mean, we could just multiply all across. It's a little complicated. Well, let's think about it like this. We've got a 5, we got a 5. Let's start simplifying across some of these fractions. So we could divide, we look right here, we got a nice little thing that we can simplify. We can take 10 and divide it by 5 and we get 2. 5 divided by 5 and we get 1. Okay, that makes it a little easier. What about 4 and 24? Let's divide both of those by 4 and we get 6 and we get 1 up top. That 19 is a prime number, not much we can do there, but I think this is pretty good. So let's multiply across. We got 38 on top, and on the bottom we got 5 times 6, which is 30. And oh, we could have done one other simplification. Let me hold up on this. We now still got a 2 and a 6. Divide those both by 2. And we can get 1 and 3. Now we'll get a perfectly simplified fraction. So it ends up being 19 over 15. It would have worked before. Anyway, it doesn't matter. This is just a little easier. So we don't have to divide by 2 again later. So now we got 19 over 15. If you want to completely simplify it, we can take out the whole number. There's a whole number in here because we're larger than the denominator on the numerator. That means this is greater than 1. So all we do is we take out 15, we take out whatever the value is in this numerator, we take it out from the denominator, excuse me, we take it out from the numerator, and that gives us a whole, and whatever remains after you take 15 out, which is 4 15s. Don't forget that negative at the end. There's our answer for 32. Let's go on to 40, a big multiplication problem. Again, first step, we're turning everything into an improper fraction. So we got negative 9/10, that guy's good. We got, let's write it all out here. We got 9/10 times, let's make this even an improper fraction, right? 7/1. We do the same process here. 2 times 3 gives us 6, plus that 1 gives us 7/3, and then times 1/21. A nice fraction there. To begin, let's do our little simplification. Let's knock out these guys, divide both by 3, this becomes 1. 9 divided by 3 is 3. Again, this whole answer is going to be negative because this one guy has contaminated the lot, right? The one negative sign. So we got 3 and 1, that's pretty good. What about 7 and 21? Let's cross those off. 7 divided by 7 is 1. 21 divided by 7 is 3. And now we're in good shape. Let's do it. So we got 3 times 7 times 1, which gives us 21. Over 10 times 1 times 1 times 3, which gives us 30. Oh, I missed another 3 that we could have canceled out. Oh, it's okay. We see that these both are divisible by 3, so we can do it after the fact too. It's all good. 21 divided by 3 gives us 7. 30 divided by 3 gives us 10. Don't forget that negative. And our final answer is negative 7/10. Okay, now we got a word problem. People get intimidated a lot of times by word problems. You just got to go slow, break it down, understand all the information. So a certain hybrid car can travel 1 4/11 times as far as a similar non-hybrid car with 1 gallon of gasoline. If a non-hybrid car can travel 22 miles per gallon, how far can the hybrid travel on 4/5 of gasoline? Okay, let's think about it like this. So first we're gonna just set up the problem and then we're gonna evaluate it. We've got our, let's see, we got our 22, I'm gonna set it up down here, 22, okay, for the regular car. And the hybrid car can travel 1 4/11 times this. But again, since this is gonna be a big multiplication problem, I'm gonna go ahead and convert this right up here. 1 times 11 is 11, okay? And we're just going to convert it to an improper fraction. 11 plus 4 is 15. Let's make this into an improper fraction. Times 15 over 11. That is our improper this is our mixed number converted to an improper fraction. Times, now why am I doing one more multiplication? Because this right here would just give us how far it can go in 1 gallon. But now they've only got 4/5 of a gallon. So we got to take 4/5 of whatever this quantity is. 4 over 5. And see, again, multiplication. We talked about the commutative property in chapter 1. The order doesn't matter. That's the beauty of it. We can put the 4/5 at the beginning, at the end. It's irrelevant. Now, before we carry this out, let's do a little simplification. Make it a lot easier. Look at 11 and 22. They can both be divided by 11. 11 divided by 11 is 1. 22 divided by 11 is 2. We got 15 and 5, both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. Now look how nice this is. We got all 1s on the bottom. We got a 2, 3, and a 4. What's 2 times 3 times 4? That equals 2 times, let me make sure I'm getting this right. 2, 3, 6, 4. Okay, again, just making sure. We've got 24 miles. And that makes sense too, right? Like, we know if it was 1 mile, it would go a fair amount farther, almost like 1.3 times farther, something like that. But we only got 4/5, so it's a little less, so it's not that much bigger, but it still should be farther than 22. 24 miles makes a lot of sense. Finally, let's go to this guy. We got 48, 3/4 of a year equals how many weeks? Well, the nice thing to do here, what I would do is we got years over here, we got weeks over here. Let's convert a year into weeks, right? Let's make this skinnier. How many weeks are in a year? 52. Okay, so then we want 3/4 of that 52. Well, all we do is we carry this out and we got our number. But again, multiplication, let's convert it to an improper fraction. And we can do some simplification. I don't know if you remember, we just talked earlier, maybe it was another lesson. 4 and 52 can both be divided by 4. 4 divided by 4 is 1. 52 divided by 4, believe it or not, is 13. And then now we just carry this out. What's 3 times 13? Gives us 39 over 1, which is the same as 39 weeks, and done.